In this lesson, we will learn how to tackle questions involving percent increases and decreases. Now, in the question shown here, we are told that the deer population increased from 40 to 52, and we want to determine the percent increase in population. Now, in this lesson, we will examine two similar strategies for finding the percent change from one value to another value. One approach is to apply the following formula that says we can find the percent change by dividing the change by the original value and then converting the resulting fraction into a percent. So, to find the percent change in this question, we must first determine the change in values. Since the population went from 40 to 52, the change is equal to 52 minus 40. From here, we divide the change by the original value, which is 40, since this was the original deer population before the change. At this point, when we simplify the numerator, we get 12 over 40. And now our task is to convert this fraction to a percent. One option is to perform long division and then take the resulting decimal and convert it to a percent. Another option is to first simplify 12 over 40 by dividing top and bottom by 4 to get 3 over 10. Now, since we already know that 1 over 10 is equal to 10%, 3 over 10 must be equal to 30%. So the deer population increased by 30%. Now, another way to calculate percent change is to apply this formula, which is closely related to the first formula. So to calculate the percent change in deer population, we first calculate the change in population, which is 52 minus 40. Then we multiply the change by 100 and divide by the original value, which is 40. When we simplify the numerator, we get 1200, and 1200 divided by 40 is 30. So when we apply this formula, we still get a population increase of 30%. Alright, let's try another question. Here we are told that a shirt that regularly costs $60 is on sale for $51, and we want to determine the percent discount. In other words, we want to determine the percent decrease in price. To calculate this, we will apply one of the percent change formulas. So the percent change is equal to the change in price, which is 60 minus 51, times 100, divided by the original price, which is 60. When we simplify the numerator here, we get 900, and 900 divided by 60 is 15. So the change in price from $60 to $51 represents a 15% decrease in price. Alright, now let's solve the same question using the other percent change formula. So, to find the percent change using this formula, we first find the change in price, which is 60 minus 51, and this is divided by the original price, which is 60. When we simplify the numerator, we get 9 over 60. At this point, our task is to convert this fraction to a percent. One option is to perform long division and then take the resulting decimal and convert it to a percent. Another option is to first simplify 90 over 60 by dividing top and bottom by 3 to get 3/20ths. From here, if we multiply the numerator and denominator by 5, we get the equivalent fraction 15 over 100. Since 15 over 100 is equal to 15%, we can see that the price decreased by 15%. Alright, now let's move from percent change to successive changes. In this question, Hilda buys hats at a certain wholesale price and then sells the hats at a retail price that is 20% greater than the wholesale price. Then, for a sale, Hilda reduces the retail price by 15%, and we want to determine the net effect of the price increase and decrease. Now notice that the question does not ask us to find any actual prices. It asks us to find a percent. As such, we can assign any value to the original wholesale price. Now, when working with percentages, it is easiest to work with 100. So let's say that the original wholesale price of each hat was $100. So once Hilda purchases the hats for $100 each, she increases the price by 20%. Since 20% of $100 is $20, we know that she increases the price by $20, which means her retail price is $120. Next, we are told that for a sale, Hilda reduces the retail price by 15%. So we need to calculate 15% of $120. Well, we know that 10% of 120 is 12, so 5% of 120 must be 6. This means 15% of 120 must equal 18. So for the sale, Hilda decreases the retail price by $18 to get a sale price of $102. Now the question asks, the net result is the same as increasing the wholesale price by what percent? In other words, we need to calculate the percent change from the wholesale price to the sale price. So to do this, we will apply the percent change formula. So the net percent change is equal to the net change in price, which is $102 minus $100, times 100 divided by the original price, which is $100. When we evaluate all of this, we get an overall price increase of 2%. At this point, we can use the results from this question to make some useful observations. Let's say we are told that the price of an item is increased by 20%, and we want to determine the new price. So if the original price is $100, then increasing the price by 20% means increasing the price by $20, which gives us a new price of $120. Similarly, if the original price is $30, then increasing the price by 20% means increasing the price by $6, which gives us a new price of $36. In general, if we have a price increase of 20%, the new price will be equal to 100% of the original price, which is the original price, plus 20% of the original price. In other words, the new price is equal to 120% of the original price. Another way to say this is, the new price is 120 over 100 times the original price. To further generalize this, we can say that if there is some percent change, then the new value will be equal to 1 plus or minus the percent change divided by 100, all multiplied by the original value. Okay, now let's apply this formula to some questions. Here we are told that McBurgerland sells hamburgers for $8 a piece. So if during a sale the price is decreased by 25%, we want to determine the new price of a hamburger. So to find the new price, we need the percent change, which is 25%, so we can add this to our formula. Notice that since the price is decreased, we are subtracting 25 over 100 from 1. Now since we are told that the original price was $8, we will add this to our formula as well. From here we can convert 25 over 100 to the decimal 0.25, and when we simplify 1 minus 0.25, we get 0.75. So the new sale price of each hamburger is equal to $0.75 dollars. Alright, let's try another one. Here we are told that the wolf population used to be 60, but it has since increased by 300%. Our goal is to calculate the new population. To do this, we will apply the following formula. Now first, the population increase is 300%, so we can add this to our formula. Next, we are told that the original population was 60, so we can add this to our formula. From here, we can simplify 300 over 100 to get 3, and now we can add 1 and 3 to get 4. Finally, 4 times 60 equals 240, so the new population is 240 wolves. Now let's take what we know about calculating new values following percent changes and make some observations. For example, let's say we begin with the number 58 and we want to increase it by 35%. This is the same as taking 58 and multiplying it by 1.35. The reason for this is that 35% is equal to the decimal 0.35, so when we add this to 1, we get 1.35. Similarly, if we begin with the number 335 and we want to decrease it by 30%, this is the same as taking 335 and multiplying it by 0.7. The reason for this is that 30% is equal to the decimal 0.3, so when we subtract 0.3 from 1, we get 0.7. Now before we end this lesson, we should discuss a common mistake that students sometimes make regarding percent increase and decrease. For example, consider this question where the price of a widget was $50 in 1980, but today its cost is 80% of the cost in 1980. To calculate the cost of a widget today, we must recognize that today's cost is 80% of $50. So to calculate this cost, we can convert 80% to the fraction 80 over 100 and multiply it by $50. Or we can convert 80% to the decimal 0.8 and multiply it by $50. Either way, the result is the cost of a widget today is $40. Now compare that question with this one. Here, the price of a widget was still $50 in 1980, but today the cost of a widget is 80% greater than the cost in 1980. For this question, we calculate the cost of a widget today by applying the following formula. Here the percent change is 80%, so we can add this to our formula, and the original cost of a widget was $50, so we can add that here. At this point, when we evaluate the right-hand side, we see that the cost of a widget today is $90. So as you can see, there is a big difference regarding the phrase of the and the phrase greater than. Okay, let's summarize. In this lesson, we learned how to calculate percent change, and we learned how to calculate new values following some percent change.